Hi, hello friends. Welcome to the today's session. Welcome to Unacademy and welcome to my classes. In this session, we are going to discuss about binary exponential backoff algorithm. What is its importance and how it is going to use and what is its main role, especially in LAN technologies like Ethernet. So we are going to discuss such kind of things in this lesson. So before entering into the lesson, let us all say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has provided a wonderful interface to the dedicated students and very good content which is developed and developing by dedicated faculty members. So these are all only for your beneficial. So utilize this opportunity what the Unacademy is providing just by giving your valuable admission. So once you give your admission, then your goals automatically are going to be cleared and achieved because your goal is our goal and our goal is Unacademy's goal. So keep it in mind. And myself is Srinivasarao Sir, having more than 15 years of experience in the GATE with the various subjects in computer science. Also had industry experience in the back-end side, that's a database and networking, with the relevant good certifications in database and networking, especially Cisco and MCSA and Red Hat Linux. Dear friends, throughout my journey of GATE, I taught in many premium academies with a high success rate, and many of my students got completed their post graduation from India's topmost institutions. They are IITs, NITs, and central universities, and they settled in their life in a higher positions. He also can able to use this wonderful chance just by clearing GATE examination. But to clear the GATE examination, there is a one important point. What is that? A need of a proper guidance and a need of tips and shortcuts. So those such kind of tips and shortcuts and guidance is Unacademy ready to provide you just by taking a valuable admission using either plus subscription or using iconic subscription. Dear friends, iconic is a one unique program which is offering by Unacademy where you are going to see a dedicated lectures. Along with that, you are going to get 1:1 personal training. So that is a unique program you never seen earlier. Dear friends, according to the Plus program, if you take an admission into Unacademy, then you're going to see that unrestricted access. You become a premium member such that you can access live sessions, live quizzes, mock sessions, recorded lectures, whatnot. Everything is readily available in an Academy portal. Whatever is there in an Academy portal, immediately you will get a notification message. Based on that, you can able to use it. So easy platform, easy communication that is provided by Unacademy. So according to the subscription prices, my dear friends, these are the subscription prices like a 12 months and 18 months and 24 months. You have to focus. So current fourth year students can go for this, and the first and second and third and fourth year students, please you prefer super long term, that is a 24 months subscription. So you want to stick it on to 18 months subscription, it is also better to if second and third year students, please refer to that. And you also going to get a very good amount of concession just by using my referral code. So use my referral code and get the maximum discount benefit on the subscription prices. And the other kind of a program is iconic batch. So in iconic batch, it is a consists of 1:1 personal coach, as well as that inbuilt it is having a plus program. So utilize this unique program which is offering by Unacademy and use my referral code. It is also eligible to get the admission into Unacademy. So after applying my referral code, then you're going to see that a maximizer discount prices like this. And my referral code is eligible for any kind of a course. There's not only for a GATE and ESE. Please utilize this opportunity. That is a free for iconic batch. So if you are having any doubts, please reach us just by filling this form. Then Unacademy is going to direct one educator or a person who can able to assist and who can able to clear all your doubts. Dear friends, whatever queries you are having, you can reach us. Just we are going to guide you. And Let's Crack GATE CSE is our YouTube channel. Subscribe our YouTube channel, hit the bell icon for latest notifications and updates, and use my referral code to get the admission into Unacademy. So if you use my referral code, then I am going to be your guide, so that whatever the guidance I can give you, I can able to give you those who are joined under me. Because every day I'm going to contact with all my students who have used my referral code. That means they have joined under me. So I'm sharing all my knowledge, and the alumni which are there under me. So they're also giving some kind of guidelines to the students who have enrolled. So utilize this program and use my referral code so that I can able to your guide, and immediately your credentials will come to me so I can able to interact with you. Friends, let us start our session. So our session is binary exponential Backoff algorithm. So one query has come from our friend Shivakumar Reddy. Is it possible to just qualify GATE CSE with practicing? Yes, you can qualify. So whatever subjects I am teaching, please go through them. You want to still in depth, please give your valuable admission into Unacademy. Therefore, I can able to guide you completely, not only for the GATE examination, and it may be also useful for campus placements and PSUs also. So now let us start. What is the benefit of binary exponential Backoff algorithm? So last session we have discussed about, so let me go back one small recap. Last session we learned about CSMA by CD. So what is the concept? It is the concept of collision detection. So how the particular sender or a node can able to identify that there is a detection of collision just by taking your average transmission time must be greater than is equal to 2 into your propagation time when there are no repeaters. So therefore, why we are using a 2 into TP time? Because last bit of your data supposed to see that are there any kind of collision signal is coming back from other party. So one TP we understand for data propagation, and other TP we understand that collision signal propagation. So collision signal propagation. So you need to wait till you get the collision signal back, if at all are there any collisions. If no collisions during this particular time, 2 into TP time, then the node feel very happy that the transmission is success. If collision signal has come during this 2 into TP time, then node will understand that our data frame has lost during the last transmission because of collision. So the node has to retransmit the same frame once again because it's already garbled or lost. So this is how we understand what? So whenever nodes are involved in the collision, so whenever your data of nodes are involved in the collision, assume, let me give one sample example, N1 and N2. Unfortunately, due to propagation delays, N1 data is also in the media and N2 data is also in the media. So somewhere they are going to get a collision. So whenever their collisions are meet, that means data signals are meet at a certain point, then it's a meaning of collision. What is a collision? Data signals of different nodes meet at a point, meet at a point, it's a contention slot, meet at a point is known as collision. So whenever you get the collision, then you see that the collision signal with a double energy is going to traverse back, and a collision signal is going to give you double energy with other node. So this collision signal also take one propagation time because it has to traverse entire your distance of the medium. That's why we understand that 2 into TP time is a mandatory to wait. Minimum frame transmission time must be 2 into TP time. So we got the collision signal. So when you got the collision signal, immediately node 1 stop the transmission, stop the transmission. Then you need to wait up to how much time? Wait up to back off time, back off waiting time. And this node also, as it is under collision, it immediately stop the transmission as there is a collision in the medium. Stop the transmission. Again, it has to wait up to back off time. So that means last session I said a very important point. What is that? Whenever data bits are collide, whenever data bits are collide for the first time, whenever data bits are collide for the first time, then with the help of binary exponential Backoff algorithm, with the help of binary exponential Backoff algorithm, we are not going to get further collisions. That's it. It ensures that no more further collisions. No further collisions. Because your waiting times are different. Because waiting times are different among the nodes. That's it, my dear friends. So unfortunately, there may be a chance that collision may happen for the first time, but as I am using CSMA by CD is using binary exponential Backoff algorithm, it is not going to see that the next time onwards the same nodes are going to be under collision because it is going to provide a different Backoff time slots. So in that slot only, if you are able to transmit, there will not be any kind of collision for the next transmissions. This is the concept of what? How you see that next further collisions can be reduced. This is all because of what? Binary exponential Backoff algorithm. The power of CSMA by CD is what? Detection of collision by sending a jam signal. I already told you. Detection of a collision just by sending a jam signal to the nodes who are involved in the collision. So whenever nodes receives the jam signal, they understand that their previous transmission is lost because of collision. Then immediately sender has to stop. It will not transmit. It waits for one certain amount of time. That certain amount of time CSMA by CD cannot decide. That certain amount of time is decided by binary exponential Backoff algorithm. So that's what today's our agenda. So what a binary exponential Backoff algorithm is saying. Backoff algorithm gives waiting time when a node's involved in the collision. If station involved in a collision, then it decides that After how much time of amount the station should wait for the retransmission, because already your previous data is lost. How much time is decided by Backoff algorithm. So Backoff algorithm grows exponentially. So it is called as exponential Backoff algorithm, right? So how this algorithm is going to work? What are its advantages? What are its disadvantages? We will see. So according to that, Backoff algorithm is applicable only for two hosts. That's why it is a binary exponential Backoff algorithm. So disadvantage and advantage. Advantage is that, as we understand, next further collisions you don't expect. This is the advantage. What is that? Providing Backoff waiting time. Providing Backoff waiting time. You may guess that. What is the advantage by providing Backoff waiting time? Yes, there is advantage. What is that? So, next further collisions would not be among nodes. This is the advantage. And the disadvantage is whoever wins for the first time, that means whoever got the first time 0th waiting time, then that node is going to capture the channel for the next transmissions. The node who failed for the first time in the retransmission, then he is going to underweight for the channel. Therefore, it is the concept of what? Capturing the channel, and it also leads to sometime starvation to other particular node who is waiting for the retransmission of its first transmission and to access the channel. So how the capturing effect is going to come and how the starvation is going to come to another node, we will look at in this session. So what is the capturing effort? We will see that. So what is the algorithm process? Set your slot time to 2 into TP. This is the first one. So after first collision, because first time we will see that whether they are under collide or not. After first collision, your slots are 0 or 1. Now you need to decide which slot you are going to take. After ith collision, your slot numbers are 0 to 2 power k or I minus 1. Here k is nothing but number of times collision occurred. Number of times collision occurred among nodes. Among data of nodes. So, but you need not wait. Actually, we will say that how long this process can goes on. So naturally, according to our textbooks and reference books, we understand that maximum collision number is going to be 15. So what is the meaning of 15? So 0 to 15 we will wait. But whenever your collision number, that means the stations got collide up to the 0 to 15, and the next 16th attempt we are going to give up. So we will hands up that the other guy is lost. Those who are under waiting, he lost sensing of your data because already you got reached to 0 to 15 slots are completed, you reach it to 16th slot. So whenever you reach to 16th collision number, then we will give up and we will terminate automatically from your shared channel. But naturally you need not go up to 0 to 15. Whenever your collision number is 10, your channel is saturated and automatically the winning chances are goes to the guy who wins for the first time, right? That's why saturation slot number is a 10 and your give up slot number is what? 0 to 15. At 16th slot, it is going to give you a give up that you need not wait under waiting to access the shared channel. So what is the algorithm process? So Rockstar07, what is your gate rank? What is the rank you are expecting by you in 2021 gate, my dear friend? Tell me. So by listening all these lectures and by taking admission into Unacademy, what is the rank you are expecting? That first you tell me. So let me explain first of all how this algorithm works. So assume node 1 and node 2. There are two nodes. Excellent. Very nice. So that prediction is required. So node 1 and node 2, first listen algorithm carefully, is sending packet 1 and node 2 is also sending packet 1. Observe how this algorithm works. So unfortunately, this data packet 1 and this data packet 1 is under collision. So when you are under collision, please observe carefully. Unfortunately, they are under collision. Why they collision? I already explained. Please watch my previous lecture. How even though we are using CSMA by CD, naturally CSMA is going to give you that 100% collision free. But unfortunately, because of propagation delays, still there may be minute of collisions are there. Minute of collisions. Unfortunately, here nodes are not involved in the collision. Please observe. The packet 1 of node 1 and packet 1 of node 2 unfortunately in the collision. So whenever you got the collision, so we are starting. Initially our collision number is 0. No collision. 0 means no collisions. Now you see, whenever you got for the first time collision, your number is incremented by 1. So you got collision number 1. Now the binary exponential Backoff algorithm is saying that choose a random number between, please understand carefully, choose a random number between 0 to 2 power k minus 1. Here k is nothing but number of collision. First time we are got collide, that's why your number is incremented from by 1. So 0 plus 1 is a 1. So now 0 to 2 power 1 minus 1, which is nothing but 0 comma 1. And this side also, because the binary exponential algorithm is running at node 1 as well as node 2, both at a time it is running. So choose random number. Very important question in the exam. Choose random number between, again, 0 to 2 power k minus 1. Here your collision number at your side is 0 to 2 power 1 minus 1. So therefore, you also got 0 comma 1 slots. Now the binary exponential algorithm is trying to keep the race between n1 and n2. So it is starting the probability race. What is the probability race? Let me explain. So n1 got 0 comma 1 and n2 got 0 comma 1 slots. Now we start keep the probability race 0 and 0 combination, first slot and first slot, 0 and 1 combination, second slot with a first slot, second slot with a second slot, right? So if node 1 choosing 0 slot, if node 2 also choosing 0 slot, what will happen? Their both of them waiting time is 0 only, because your waiting time, the Backoff waiting time is a small equation. your back-off waiting time is a small equation. What is that? Your collision slot. Your collision slot number. You need to decide which collision slot you want to decide. And we know as usually 2 into TP. Right? So now I'm taking let 2 into TP is something like 100 ms. Assume. In exam, we will say that what is the 2 into TP time. So this side, data propagation is a 50 ms, and it may be, if at all any collisions are there, it takes a collision propagation time 50 ms. This and this is all together 2 into TP. Okay? If both of them chosen 0 and 0, exactly here, their waiting time, N1 waiting time is 0 to 100 ms. And N2 waiting time is 0 to 100 ms. Therefore, both of them waiting time are going same. So again they are going to propagate. Again they are going to send the data on the medium. Again what will happen? They will fall into collision. That's why the first combination goes to collision probability. And the second combination, if A chooses, N1 chooses 0, if N2 chooses 1, this is the combination which I am talking. Therefore, what is N1 waiting time? As you choose in 0, 0 into 100 ms, which is nothing but 0. If N2 chooses 1, so 1 into, your slot number is a 1. 1 into your 2 into TP is 100 ms. So your waiting time is more than me. My waiting time is 0 and your waiting time is what? 100 ms. So if A chooses 0, if N2 chooses 1, then who will win the race here? Chance of A only. Probability to win the race by A. Probability to win the race A. And the next slot, if I choose 1, if other guy chooses 0, what will happen? My waiting time is reverse. It is 100 ms. And as you choose in 0, his waiting time is 0 into 100 ms. It is 0. Therefore, who will win the race here? And the winning capability of the B is this. So in this case, B will win the race. And now the last equation, what is that? Both are choosing 1 only. So 1 into 100 ms is nothing but 100 ms. And here also same. 1 into 100 ms, if I choose, then it is also what? 100 ms. So both will wait exactly 100 ms. Again they are sending the data. Again your data is under collision. That's why this is what? Collision probability. So in the first itself, this is your first phase. This is your first phase. In this first phase, what will happen? We got some probabilities. What is the probability? Please understand. In the first phase, at the end of the first phase, you got collision probability 2 out of 4. And A winning probability, that means node 1 winning probability. How much? Node 1 winning probability, 1 chance out of 4. And node 2 winning probability, only 1 chance out of 4. So any doubt you can ask me. Thank you very much, my dear friend. So please give comments in my lectures and please do like my lecture. And now this is your first phase. So collision probability is more than this. So A's winning probability and N2 winning probability is the same. So now I need to give you a clarity. What is that? Who is going to choose 0th slot and who is going to choose 1 slot? So in exam, examiner will tell you. So here, choosing a slot is crucial, right? That's why, my dear friends, observe carefully. I am giving you clarity. What is that? If N1 chosen 0, if N1 chosen 0th slot, automatically next slot will be assigned to N2. Then N2 is assigned by first slot. Therefore, what will happen? So according to our story, as A is chosen this, and B is chosen this. So in that case, A waiting time is 0. So immediately you can write retransmit, and B suppose not to retransmit, you have to wait up to 100 ms. So here what is going to happen? Observe carefully. So in this, after first phase, please listen my dear friends. After first phase, N1 packet 1 is under collision with N2 packet 1. So N1 chosen 0 slot number. So your waiting time is equal to 0. N1 chosen 1 slot number. His waiting time is nothing but what? 1 into 2 into TP, which we guess that 100 ms. That's it. So what will happen? A win the race in this. That means N1 wins the race and access the channel. Only one node is available right now, and access the channel and retransmit whatever data is lost. Retransmit packet 1 once again because it was lost. So whenever collision happen, your data signals are going to be lost. So I will retransmit. So when you retransmit it, you will be 100% success. But N2 is still waiting for what? Packet 1 retransmission. Any doubt, tell me. So let us see second iteration, second phase. So N1 packet 1 is success, but N2 packet 1 is lost, is under waiting for retransmission. Waiting for a retransmission. Right? So now N1 is releasing packet 2, the new packet. N1 is still waiting for retransmission. Right? How long is waiting for retransmission? I already told you. After 100 ms, N2 got chance and N2 retransmitted. So when N2 retransmitted, what will happen? So after this, please understand, after this step, so N2 retransmitted packet 1, and this side also packet 2 sent by the N1. N1 released a new packet 2. A new packet number is 2. Now unfortunately what will happen? The data of a packet 2 and the data of this packet 1 unfortunately actually never have in real time, but if at all, if they are under collision due to some reason, then what will happen? Again, the N1 has to choose the slot number, N2 has to choose the slot number. How they are going to choose the slot number in the second phase, we will see. Now we are talking about N1 packet 1 success and N2 packet 1, it is retransmitted. So when it is retransmitted, this and this is under collision, right? Now my collision number starts with 0, and this collision number, it is incremented earlier with 1 and now it is incremented to 2. Please observe this logic. What is the logic? Your packet 1 of node 2 is a collide for the second time. Please understand. Your packet 1 of a node 2 is a collide for the second time. But here, the packet 2 of node 1 is a collision for the first time. Please understand. So he got the collision for the first time. Which packet this is? P2, as he released a new packet. And this is under collision. So again, your collision number starts with the 0. As my data is involved in the collision, therefore your number is incremented to 1 and your number is incremented to 2. Please understand. So you may get a doubt that why N1 got again collision number 1, it should be 2. You may guess no, because packet 1 is already went successfully. Now he is testing with packet 2. Again, for every packet you are going to get a collision number 0 starts. Then it is going to be updated. Now again there is a race. 0 to 2 power 1 minus 1. You got 0 comma 1 slots. Now you got 0 to, this time your collision number is increased. So you got 4 slots now. 0, 1, 2 and 3. Now keep the race among them. Now N1 and N2, they are on the race, probability race. First slot is 0 to 0. And the second slot is 0 to 1. Next slot is 1, 0. Let us see another slot. 0 with 2 and next slot is 0 with 3. That means the first slot of N1 is having the probability with all other slots. Now 1 0 and 1 1 and 1 2 and 1 3. Okay, let us see that if they choose the first combination, what will happen. If they choose the first combination, it is a collision. If they choose second combination, N1 waiting time is 0. If they choose a third combination, N1 waiting time is 0. If I choose a fourth combination, N1 waiting time is 0. So if I choose a fifth combination, this is the crucial. If I choose a fifth combination, N2 winning probability is 0. He will try to access the channel. And if I see that 1 1 slot, both are waiting time is 0, collision. If I choose a 1 2, my waiting time is lesser than N2 waiting time. And my waiting time is less than waiting time of N2 in the last slot. Now you tell me, your collision probability, how many? 2. 2 out of 8 slots. And the N1 winning probability, how many slots N1 can able to win? 5 slots, 5 out of 8. What is a N2 winning probability? Only 1 slot. That is nothing but 1 slot out of 8. So here A has got much more probability. That means N1 has got much more probability than N2. Therefore, here also who is going to win? N1 is going to win once again. So let us continue. At the end of second phase, at the end of second phase, N1 got more winning chances. N1 got more winning chances. Therefore, N1 wins the race. Winning the race is nothing but capture the channel once again. Capture channel. And whatever the data you lost because of collision, please understand. Whatever the data you lost because of collision, which data you are losing? P2 data you lost because of collision, that P2 I will send back once again and capture the channel and retransmit packet 2 once again. Therefore, what will happen? N2, earlier P1 is success and P2 also success. But what about N2? Your N2 is still under waiting. So N2 waiting for retransmission of P1. P1 is nothing but first packet. Any doubt, please chat with me. Now you see, third case we will say, phase 3. So in first 2 phases, N1 only 1. Phase 3 we will see. I am giving you case study. N1 packet 1 success, packet 2 also success, and he start releasing packet 3. Here N2 is 2 times got failure. So still his packet 1 is under waiting for retransmission. Waiting for retransmission. So after some time, you know which some time, you may choose these slot numbers. You may choose only one slot number. What is the one slot number? This one. So if you choose any other slot number, your waiting time is more. Please remember that. After some time, as N2 got win the race, so your waiting time is more than N1. After some time, N2 released, retransmitted packet 1, which is under waiting. Now unfortunately what happened? P1 is going into the channel and P3 is also going into the channel. Unfortunately, examiner will tell you all these case studies. Again, they are under collision. And now they are going to get the collision numbers. So your packet 3 is a new packet which is a collision first time. But your packet 1 is already 2 times collide. Now your collision number got 3. Again, you got the slot numbers. So what is that? 0 to 2 power k minus 1. Again, you got the same concept, 0 to 2 power k minus 1. So both of them are going to get, this is N1, this is N2 case study. So your slot numbers are 0, 1 and these slot numbers are increased 0, 1, 2, 3, 4, 5, 6, 7. Because your collision slot number is a 3, 0 to 2 power 3 minus 1. 0 to 2 power 3 minus 1 is nothing but 0 to 7. So I got the slot numbers. Again, I am keeping them into what? Probability. You know. Now you can easily say who is going to win the race. Please chart with me. Who is going to win the race? 0, 0 case, 0, 1 case, 0, 2 and 0, 3 and 0, 4 and 0, 5 and 0, 6 and 0, 7. And again 1, 0 and 1, 1 and 1, 2 and 1, 3, 1, 4 and 1 and 5, 1 and 6, 1 and 7. Total slots are 16. 2 into 8, which is nothing but 16 slots. See that his waiting time is exponentially increased. First 2 power 0, collision number 1, then 2 power 1, collision number 2, then 2 power 3, collision number 3. That means exponential waiting time you are going to get. Now who is going to win? This is N1, this is N2. According to that, this is a collision chance. And this is your collision chance. Collision probability, collision probability. Out of 16, 2 are collision probability. And the remaining case study, N1 waiting time is lesser than N2 waiting time. So N1 waiting time is lesser than N2 waiting time. Therefore, A winning probability, N1 winning probability is nothing but what? How many chances? So 16 minus 2, 14. And you are getting a 13 chances out of 16 chances. And N2 has got only one winning probability. This is only N2 winning probability. So your winning probability 1 out of 16. Your collision probability 2 chances out of 16. Right? Again, who is going to win? The winning chances of N1 is go more. Therefore, what will happen? After third iteration, at the end of third iteration, so what will happen? N1 retransmit packet 3. N1 retransmit packet 3 because it was lost due to congestion, due to collision. Retransmit packet 3. Therefore, what will happen? N1 packet 1 success and packet 2 success and packet 3 success. But what about poor N2? Please understand. N2 waiting for packet 1. Waiting for a retransmission of packet 1. So likewise, what will happen? Every time N1 is going to capture the channel, N2 is going to lose. How long? This is what is the case study. How long N2 fight with N1. How long? Is it infinity? This is my question. Is it infinity? No. So when you reach to k is equal to 16th collision, when k is equal to 16, then immediately channel throws an error that you cannot wait. So that you need to recome once again, rejoin once again, but don't be in the waiting right now because already you reached your attempt. So therefore what will happen? N2 disconnected. This is your telephone real-time example. What is that? When two parties are communicating each other and third party has come into the middle and trying to talk with you, he will get engaged sound. How long? First time collision, second time collision. Likewise, you are going to see that multiple number of times. So we are going to wait in up to 16 slots. Exactly at when you reach to your 15 chances are completed, exactly at 16 your call is going to be disconnected. Just in general I am saying, right? So N2 got disconnected. Therefore what will happen? Up to 15th attempt the N2 is under starvation. N2 is under starvation. But anyhow, this is a limited starvation. Exactly when you reach to k is equal to 16, you are going to disconnect from your particular channel. Now, so this is giving an exception. What is the exception? When you see that k is equal to 10, your channel is saturated. When k is equal to 10, your channel is what? Saturated. You need not wait, time waste. So therefore, this is what is the meaning of binary exponential Backoff algorithm, my dear friends. So here what will happen? Whoever chosen first time 0th slot, whoever chosen first time 0th slot, then in the next come other slots, automatically that particular node is going to win the race because of Backoff algorithm, right? That's why this kind of effort is known as a what? Capturing effect, channel capturing effect. Okay. Now how to calculate the Backoff waiting time? So I will show you. Listen carefully. So waiting time of process I am going to show you. When a collision occurs for the first time, so immediately you are going to get the jamming signal to prevent further collisions. And immediately your k value is incremented from 0 to 1. So a node must go into choose your slot number 0 to 2 power k minus 1. And this 51.2 microseconds is a default. This is a default 2 into TP time. How you got, I will show you. Why did we get 51.2 microseconds as a default? I will give you one example so that you will understand. So resend a frame after either 0 seconds, because if you choose a 0th one, then after either 0 seconds, or if you choose 1 into 51.2 microseconds. So your waiting time either 0 according to first iteration, or your waiting time 1 into 51.2 microseconds. It is nothing but 2 into TP time only. So probability of collision is 1 by 2. Probability of collision is 1 by 2. Now, second time, when k is equal to 2, observe. Now node got the collision 0 to k minus 1, you got 4 slots. So resend the frame either after, so you are getting a different values. Waiting time may be 0 seconds, or waiting time may be 1 into 51.2 seconds, it's a microseconds, or 2 into 51.2 microseconds, or 3 into 51.2 microseconds. Just you take your slot number, multiply with your 2 into TP, you will get either 0 waiting time or this much, or this much or this much. But naturally we try to prefer lower slot number instead of higher slot number. So your probability of collision is 1 by 4 or 1 by 2 square. 1 by 2k, that's the meaning. So it is a 1 by 2 square. And next third one, if still you are getting collision, so resend the frame after k into 51.2. What is the k? K is your collision number. So it is going to be 1 by 2 power k. Or you can also say that if it is a third time collision, 1 by 2 power 3, and you are going to get a slots 0, 1, 2, 3, 4, 5, 6, 7. So now I am giving you exception. What is that? After kth attempt failed, resend the frame according to I said. So, but the channel is saturated exactly at k is equal to 10, and you can be under waiting till your 0 to 15 slots are completed. Whenever 0 to 15 slots are completed, when you reach to k is equal to 16, then automatically you're going to what? Error message you are going to get. So automatically you're going to disconnect once you reach to k is equal to 16. So what do we understand, my dear friends? What do we understand? So it is providing waiting time in the form of exponential. First 2 power 0, then 2 power 1, then 2 power 2, then and so on 2 power k. Now when you get this collision number 1, so 0 to 2 power 0 minus 1, and it is 0 to 2 power 1 minus 1, and it is 0 to 2 power 2 minus 1, and so on 0 to 2 power k minus 1. That's why your waiting time is in the form of what? Exponential. This is called exponential algorithm, and it is going to provide a what? Backoff waiting time. Backoff waiting time it is going to provide, hence it is known as exponential backoff algorithm. Let me explain one important point. Let two stations involved in the collisions, two stations involved in the collision during transmission of the data, and collision number is giving you, collision number is equal to something like 3, and is also giving you TP is equal to 30 microseconds. He is asking you what may be the waiting times. What may be the waiting times? Now I am showing you different kind of waiting times. I will say they are all correct only. First, so you got collision number is equal to 3, which is nothing but k is equal to 3 only. So you know k is equal to 3 means 0 to 2 power 3 minus 1, which is nothing but 0, 1, 2, 3, 4, 5, 6, 7, right? So your waiting times are, this is what is the meaning of backoff waiting time. Your backoff waiting time is nothing but 0 into your 30 microseconds or 1 into your 2 into TP, no? 0 into 60 microseconds or 1 into your 60 microseconds or 2 into your 60 microseconds, and so on, maximum 7 into your 60 microseconds. Please understand. So this is what is the meaning of what? An example, minimum time and maximum time. So I said that the default is a 51.2 microseconds. So what I said, default your round trip time is, I said, 51.2 microseconds. How did I get? This is according to standard Ethernet, basic Ethernet. Your basic Ethernet frame is 10 base 2. So what is the meaning of 10 base 2? 10 stands for 10 Mbps and 2 stands for 200 meters. This is the first one important point. And the second important point is your frame size is a 512 bits. Why? We will see in the tomorrow's Ethernet class. Your frame size is a 512 bits default. So what is your transmission time? Your transmission time is nothing but what? Please observe. Double of your propagation time. Your round trip time is nothing but your TT greater than. So your TT is supposed to be double of your TP. So your transmission time is 512 bits divided by 10 Mbps. Or you can also call it as L divided by your bandwidth. So it is a 51.2 microseconds. So this is how we got your basic Ethernet 51.2 microseconds. Right? Why? Because we have equation. What is that? Your TT is equal to your 2 into TP. That's why I calculated TT here as a 51.2 and I am assigning to your 2 into TP. So let us start. 3 questions I want to discuss. First question is, this is one of your previous GATE question. Station A and B are ready to send frames and they collide for the first time. So when they collide for the first time, examiner is concluding that A wins the first phase. A wins the first phase means what? So A collision number and B collision number is same only, 1. So E might have chosen 0 slot number, E might have chosen 1 slot number. That's why A wins the race. Because your waiting time is a what? 0 and your waiting time is a 1. 1 into your 2 into TP. That's nothing bad. So after end of successful transmission by A, both A and B attempt to transmit once again and collide. So second phase he is asking the probability that A wins the second backoff race. So second phase you listen. What is the second phase? If you look at the second phase is, so he is asking about A and B. First K is equal to 1 and K is equal to 1. A chosen 0. A chosen 0th slot and B chosen first slot. Therefore, what will happen? A win the race. So, what is the meaning of winning the race? A retransmitted the first packet. Now, after that, again A is sending packet 2. This is about packet 1. And still, as B lose the race, B lost race because your waiting time is more than your A. And still P1 is under waiting. So examiner is saying that this and this is under collision. So now you got the collision numbers. You may guess me. Collision number, first time it is a colliding and it is a second time it is a colliding. So what are A's and B's collision numbers? A and B, 0 to 2 power 1 minus 1, which is 0 comma 1, and 0 to 2 power 2 minus 1, which is 0 1 2 3. So if you keep probability chance 0 0 0 1 0 2 0 3 1 0 1 1 1 2 1 3, A winning probability, how many chances? 1 2 3 4 5. So first one is a collision probability because both waiting time is 0. This is a collision and this is also collision. Now one slot we are allocating because B can win the race, B winning probability. So it is a 5 by 8, which is nothing but 0.625 is your answer. So according to that, Your answer is 0.625. Very simple. Third phase means it is a 13 by 16. Fourth phase means you can calculate. And another question I want to tell you. So standard Ethernet, a station collides four times. Four times the station collide. So your collision number is 4. So how long might it take before? How long might it take before the next attempt? So you know k is equal to 4 means 0 to 2 power 4 minus 1. So you got 0 to 15. After that, so 16th slot number. Now you can able to attempt. So 0 to 15, your waiting time minimum is 0 and maximum is a 15. After that, exactly at 16, so you can able to do what? Next attempt, because you need to wait from 0 to 15. What is the meaning of waiting time here? 0 into 2 into TP and so on. Last waiting time number is 15 into 2 into TP. After this time, please understand, after this time, after maximum I am taking, after 15 into 2 into TP, a node can send, right? So standard Ethernet means 51.2 microseconds. That's your answer. According to standard Ethernet, 2 into TP is equal to 51.2 microseconds. Therefore, so your next attempt after 15, no, after 15 into your 51.2 microseconds. After that, after 15 into 51.2 microseconds, station can send. That's it, my dear friends. So this is what is the meaning of binary exponential backoff algorithm. So please give your valuable support. Please share this knowledge to all your friends, and please do like my lecture and give your valuable positive comment. Therefore, because nowadays many of the students are going through lectures only through comments and likes only. That's why I'm sincerely requesting you, not for me, it's just for the audience and any of your friends, because the guys who are studying BTech program, the syllabus is apt 100%, it is apt to them. That's why please give your valuable likes and comments. Therefore, the subject and the video is going to move to everybody else. So please stay tuned to Unacademy and stay tuned to my classes. Use my referral code. Join into Unacademy for in-depth training more than this. Join into Unacademy for in-depth training, but don't forget to use my referral code. Once you use my referral code, then your list will come to me. Then I can able to give you all my suggestions, and all my alumni is also going to interact with you. This is my referral code to get admission into Unacademy. So you will get a discount as well as my guidance also you're going to get. So all my 15 years of career track, many thousands of students are there as my alumni. So they are all going to interact with you. Thank you very much for your valuable support.